Hello friends, in this AV we are going to talk about the combination of resistors or resistances in parallel. First we'll try to understand the figure that we have made. Here a current I flows through the circuit between A and B, and we have three resistances R1, R2 and R3 which have been placed parallel to each other. Now, in parallel connection of the resistors, we have to know that the total current I will divide itself from the junction A. So, I1 goes to R1, current I2 goes to resistance R2, and current I3 goes through the resistance R3. And finally, all I1, I2 and I3 will meet at junction B, and finally we'll get the current I which will flow back. So now let's write the given things and start. So here we have written that let I1, I2 and I3 be the currents flowing through the resistances R1, R2 and R3 respectively. Now the total current that is being drawn from the battery would be given by I is equal to I1 plus I2 plus I3. Please remember that in parallel connection of the resistances, the current gets divided, but the potential difference, that is V, the potential difference will remain same for all the three resistances. So current through R1 will be I1 and I1 will be V is equal to IR. So from there I will be equal to V by R, and as I told you, the potential difference remains the same in all the three resistances. So V will be written as V itself and resistance is R1. The value of resistance is R1. Similarly, the current I2 across the resistance R2 will be given as V upon R2. This is, mark this as equation 1, this will be 2, and this is going to be our third equation. And finally the current I3 will be given as V upon R3. So we mark this as equation 4. Now putting the value of 2, 3 and 4 in equation 1, we will have I is equal to, the value of I1 is V by R1 plus the value of I2 is V by R2 plus the value of I3 is V by R3, and the overall value of current is equal to V by the overall R, that is the resistance in parallel. So that is equal to, from here we can take V common and we will be left with 1 by R1 plus 1 by R2 plus 1 by R3. Now here V and V can be cancelled out, and our final equation for the combination of resistances in parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation for the combination of resistances in parallel. We are going to use this equation for the numerical purpose, but please make sure that when we get the value, we need to take the reciprocal of the value, because here we are calculating 1 by Rp, that is 1 by the total resistance in parallel. But for numerical purpose, we need to find the value of Rp, not 1 by Rp. So whatever value you get here in numerical, we will be taking the reciprocal of it, which you'll be seeing in the next AV, where we would be solving the sums based on this. That's all in this AV. Thank you so much. Stay blessed.